Welcome to this video on expressions versus equations. Let's begin. So, what is the big difference between an expression and an equation? If you look down here, I've given you some basic examples. So as you can see, the biggest difference between the expression and the equation is that the equation has an equal sign in it. So expressions do not contain an equal sign, whereas equations do. So now let's talk about what we can do to expressions versus equations. If you have an expression, you can simplify it, evaluate it. You might obtain a common denominator, such as in this case, 1/2 plus 1/3. You can also find restricted values. The one thing you cannot do with an expression, because you just don't have enough information, is that you cannot solve. With an equation, however, you can solve if there is a variable. Then the biggest thing that confuses a lot of people is what can you multiply by? So let's just think about something even simpler than 1/2 plus 1/3. Let's just think about the number 1/2. What can I multiply 1/2 by without changing it at all, so that it's still equal to 1/2? Well, the only thing you can multiply by and not change anything is 1. So the only thing you can multiply by if you have an expression is 1. With an equation, however, remember, I can do anything I want to the equation as long as I do the same thing to both sides of the equation. So be very careful as you go through this chapter and make sure if you have an expression, you're only multiplying by 1, whereas if you have an equation, right, you can multiply by anything. Now let's continue with the basic examples. So for 1/2 plus 1/3, if I were to actually add these fractions together, I would have to obtain a common denominator. But again, I can only do this by multiplying by 1. I can't multiply by anything else. However, over here, if I have 1/2 plus 1/3 is equal to x, the easiest way, the fastest way to do this is to multiply both sides not by 1 or by 2/2 or 3/3, but to multiply the whole equation by the LCD, or least common denominator. So let's look over here. What if I have 1 over x plus 2 plus 1 over x plus 3? So again, this is an expression, not an equation. So the only thing I'm allowed to multiply by is 1. So if I multiply 1 over x plus 2 times x plus 3 over x plus 3, well, what is x plus 3 over x plus 3? It's just 1, isn't it? Right? So I'm really just multiplying by 1. In other words, I'm not changing the truth value of this. Likewise, over here, I can multiply 1 over x plus 3 by x plus 2 over x plus 2. Again, this is just 1, so I'm not changing anything. Then, once I do that, I've obtained a common denominator, meaning I can put x plus 3 and x plus 2 over a single denominator. So that's where x plus 3 plus x plus 2 came from, right? Once I obtain a common denominator, then I can put them over a single denominator. And then, once I do that, then I can add x plus x, which is going to give me 2x, and I can add 3 plus 2, which is going to give me 5. I can't solve for x because, again, I don't have any more information. All I can do is to simplify this expression. The other thing I have to do, remember, is because this is a rational expression, I have to list my restricted values. And again, the restricted values come just from the denominator. So in this case, the restricted values are -2 and -3. So let's compare the work here with the expression to the work over here with the equation. So again, it's an equation, so I don't have to get a common denominator. I can make my life a lot easier by first finding and then multiplying by the LCD. So with rational expressions such as this one, the first thing we want to do is to factor all of our polynomials. So we've done that here in this step. X squared plus 5x plus 6 factors out to x plus 2 times the quantity x plus 3. So the LCD is going to be x plus 2 times x plus 3. So again, I'm not going to bother over here like I did over here with getting a common denominator. Instead, what I'm going to do is multiply everything through by the LCD, because as you're going to see in a minute, that is going to eliminate, it's going to completely eliminate the fractions in general. So let's look here. First, you can see what's happening is that these x plus 2's cancel out. So that just gives me an x plus 3. Then over here, you can see that the x plus 3's cancel out, so that just leaves me with 1 times x plus 2, or x plus 2. And then on the other side of the equation, both factors cancel out, so then we just have 6. So now you can see this is so much easier and simpler to work with. It's just a linear equation. So I have x plus x is 2x. I have 3 plus 2 is 5. So now all I have to do is solve the equation 2x plus 5 equals 6. So I subtract 5 from both sides. I get 2x equals 1. And then I have x is equal to 1/2. So let's take a minute and talk about the restricted values and then compare them from the expression and the equation. So with the expression, I did have to explicitly list the restricted values. I don't have to list them here. However, I do need to consider them. Because what if 1/2 was one of my restricted values? If it was, then I couldn't include it in my solutions because it would be an extraneous solution. But luckily for us, our restricted values are -2 and -3. 1/2 is neither of those values, so we can just be done and say that our final answer is x equals 1/2. So let's look at some other operations that we can perform on rational expressions. So notice that I don't have anything over here for equations, just expressions. So subtraction proceeds exactly like our addition, right? So first we have to factor our polynomial, which we did here, and then we obtain a common denominator, again, only by multiplying by 1. Remember, in all of these expressions, the only thing we can multiply by is 1. So from here, we would have a common denominator, and then we could proceed. Now let's talk about multiplication and division. Okay, so multiplication and division of fractions are different. So when we multiply fractions, all we do is multiply across from left to right. So if I have something that looks like this, first I can factor my my polynomials. As you can see, I've done that here. I factored x squared plus 3x plus 2. That becomes x plus 2 times the quantity x plus 1. I also factor 2x plus 6 becomes 2 times the quantity x plus 3. And then I factor the difference of squares, x squared minus 1, and that gives me x plus 1 times x minus 1. So I want to continue talking about the multiplication. So once we get here, right, and we have our factor polynomials, then what we can do is we can cancel out our factors. So x plus 1 is on the top and the bottom, so those are going to cancel out. Then we also have the x plus 3 upstairs and downstairs, so those are going to cancel out. So our final answer would be 2 times the quantity x plus 2 over x minus 1. But again, with our restricted values, we're going to have 1, 2, 3 restricted values because x cannot be equal to -3 or -1 as well as +1. So we would list that. The other thing I want to talk about is that sometimes when students are doing addition or subtraction, I see students cross out things like this, right? The x plus 3 cannot be crossed out or canceled out across the plus sign or minus sign. That just makes no sense. The reason we can do it here is because these are really all glued together with either multiplication or division. When you cross over a subtraction sign or an addition sign, you can't cancel it out like that. It doesn't make sense. So please be careful of that. The other common mistake that I see is, notice up here when we were adding or subtracting rational expressions, we had to find a common denominator. But notice we do not need to do that with multiplication or division. So be careful as you multiply or divide. Multiplying and dividing fractions are the easiest thing to do because why? Because you don't need a common denominator. You can just multiply across, cancel things out, and again, don't forget your restricted values. For the division, right, we would first do a keep, change, flip, where we keep the first fraction, change the division to multiplication, and then flip the second fraction, and then we would proceed exactly as we had with multiplication. So again, you can cancel things out like this when you're multiplying. You cannot cancel out across the addition or subtraction sign. Likewise, you do need to have a common denominator when you add or subtract. You don't and should not bother with common denominators because it just doesn't make sense when you're multiplying or dividing. So please be careful with that.